Ideally, this was going to lead into the financial math stuff that we all need to know, and we might even scrape in 5 minutes of it. It was going to be in our double lesson, but hey, we go with the flow, and you're going to be doing money anyway. Hey, Coops. Hey, Finn, we're missing you already. Oh, my God, they're all saying, no, we're not. How rude. JP, you can't say that. I'm just joking. No one's saying anybody. All right. So what we have at the moment is we are very good friends with our exponential functions. Are we not? We know that when we've got something up here, right, so it's not x squared, because if it was y equals something x squared, we know that it's going to look like this or like this. Agreed? The beautiful quadratics. But when we see it look like this, and you know, it could be a times 2, it could be a take 5 up here, it could be a plus at the end. But we're just going to keep it simple for today to look at this. We know that it might or should look like this, exponential. Agreed? Doesn't cut underneath. It has, what is this thing along here called? Asymptote. Yep, asymptote. And it means that the graph isn't actually going to cut that value. With some of the stuff you're doing with the graphing worksheet, if we had a, say, plus k here, that then becomes the value of your horizontal asymptote. That lifts the whole graph up. You can't see me there, but I'm using my hands, and it's lifting the whole graph up, or if it's negative, it lowers the graph. Agreed? So that's what we were playing with. We were doing a whole lot of stuff, but what we want to do today is one of the applications which relates to money. Oh, tapped it too. So we're going to look the base one here of $10,000 invested for, this is what we call a term deposit. Have you heard that before? So let's imagine you get a little chunk of money, and you are going, oh, geez, I got that big lot of money. I don't want to touch it. If I just put it in my savings account, I'm just going to pull a little bit of it out every few weeks, and it's going to disappear before I know it. So this is, I'm putting it away in a term deposit, and I can't touch it for you shut your laptop, Sam. I can't touch it for, you can like say for 6 months, for a year, for 2 years. And what we're going to say, we'll do it every year, but we're going to roll it over, so we're not going to touch it for, let's say, a long time. How many years? I have to do it different because I chose 10. So what did you say? We'll go 15. Okay? I know, I don't know why I ask you when I take myself. And the bank offers you, I mean, why do we put it in the bank to begin with? You want interest. Now, over the last few years, the interest rate has been so low, it's ridiculous, like 0.1%, right? There wasn't, but at least you were getting something and it was safe. Slowly, the interest rates are rising. On average, they used to be like 5%. So hopefully they'll get back to that. I think at the moment they're probably like 2%, very low. Good for people borrowing money, not good for people investing. Anyway, we're just going to keep it simple and say it's at 5%. And we're sticking to compounded yearly. So once a year they'll look. Now, that's not how it normally goes. They normally do it every month, and they will give you that interest, and then you'll earn interest on top of interest and so on. So how is this related to logs? I hear you ask, an exponential. If you think about it, this $10,000, it's increasing by 5% every year. Agreed? How do we increase something by 5% or even by 10% or 18%, whatever? Do we know? I love that you said that. Say it into the mic.
Times 1.05.
So we can say this in one maneuver. We times by 1.05. And some of you out there might be going, what's that 1 doing there? Isn't it that to find 5% of something, you just times by 0.05? Why is that 1 there? Anybody know? Wait. Yes?
The 1 represents the original amount of money.
Yes,
and
it's the 100% that you started with.
then
1.
The 5%, which is...
And then you add the 5%. So 105 is actually 100%. of your money plus the 5%. If instead it was decreasing by 5%, what do you think you times by? 0.95. You take it off from 100, right? So you get it in one maneuver. So that's what we get after 1 year. Then the second year happens. So we're going to increase by 5% again, yeah? So I have to times by. And then the second year, third year, fourth year, fifth year. So would it come as a surprise to you that to work this out, it would be y equals 10,000 times 1.05. Well, to the n, that's right. And in our case, our n, how long have we put it away for? To the 15. Is there anything in your memory with this? Never seen that? So, this is, it's all right. So it's a formula for a term deposit, right? Where I, any idea? Right, I is your interest rate. This, what do you think it is? Right. Yeah, no, sorry, 1. So that's your interest rate, and notice you have to put it as a decimal. And you add it to 1, and as Addie said, that's because you're adding on that original amount. What do you think? I'll tell you what PV stands for. Do you remember? That is your present value, so what you started with. Yeah? So what you started with, what do you think the FV stands for? Future value, that's right. And this can work, right, when we're growing money. So that's your compound interest formula. It can get a little bit kooky when instead of your interest being compounded yearly, you can compound it monthly, quarterly, and what have you. And you're going to see in a minute where maths is sort of changing. So some of your typical questions that we'll get from this can be, because we did the growth and decay ones with the population growing, and you had to graph it on your calculator, yeah? Yes? So, can we get our calculator out? And we want to graph this. So, to the calculators. To the calculators, Batman. Or, this is an application that's in a Kara that we have to tick off and say, you've linked exponential functions with money and compound. But we can kill 2 birds with 1 stone, because this is easily could say this is the number of bacteria increasing at 5% every hour, blah, blah, blah. Stop talking, please. So your job, can you pop this into your calculator and make it appear on your screen? So we go 1,000 times 1.05 to the, remember, it doesn't matter if it's an N or a T or what have you, to the X. We press enter. We'll pause. Missed the 0, so we all got it in. We press enter. If I went view window as my standard, I get nothing. And I should be, of course I get nothing. Because just looking at that equation, what should, you can't see the equation, what should be my y-intercept? 10,000. Why do we know it's 10,000? Because your y-intercept, Grace, your y-intercept occurs when x is 0. What's anything to the power of 0? 1, and 1 times 10,000, bang, 10,000. So if I've set my scale to stop at 10 on the y-axis, well, no wonder I see nothing. Agreed? So you've got some options. You can actually adjust the scale yourself, or you can do what I do. If we're graphing this situation, what's our x values going to go between? For 15 years. 0 and 15. Fantastic, Joel. So we're going to have minimum at 0. We're going to go maximum. You can go 15 or 16 if you want a buffer. What do you want to do? Do you want to have a buffer? Buffer of 16. Right? I don't touch anything else. Calculators are in there. And I still get nothing. And you go, what is she doing? That's okay. What do we now press? Shift, Zoom, Auto. And this is going to work every time. I'm now going to do a little bit of adjustment. I'm going to go Shift View Window and I'm going to scroll down to make my Y minimum 0 just so I can see where it goes. Oui? So you can see it's got a slight curve to it. It keeps going and going and going. Agreed? We all good? Okay, so on your calculator, and remember, you can do this stuff. This is wrapping up one of the revisions in the common test as well, because we would do exactly the same thing if it was a quadratic function instead of an exponential function. Agreed? All right, let's solve this issue. So how much will we have in the bank after Okay, after 15 years, sure. Yes, no, that's good, that's good. So how do we do it? G-solve more Y-calc 15. So simple, 20,789. Not bad, not bad. We happy with that? Now, what if it said, how long before we have 18,000? Yeah? How do we do it on our calculator? G-solve. Next. Well done. 12.04, right? Aiden, he goes, I love logs. How does this tie in with logarithms? I said, can you solve that without using technology? So you're solving 18,000 equals 10,000 times 1.6 to the x. And you need to now prove that x is 12.04. So how do I get to x? What do we do? Have a little bit of a think. Oh. Why is it 1.6? You know, again, I will defend myself slightly, but natter. But I don't know why. I've got 6 in the brain. I'll tell you. Okay, ready? What are we going to do? Ollie is on fire. We first have to divide both sides by 10,000. You can't log too early. You're writing this down. Now, I've put there, use the calculator only once. So when we've got this, I mean, clearly I don't want to write that out every single time, so this cancels nicely. Yeah? You could cancel 18 over 10, but I go, I don't want to. Weary day, you know, that's it. So, what happens at this point? I've got something equals 105 to the x. What do I have to do? Log it. Log both sides. Right? So we're going to go log 18 over 10 equals log 1.05. And what now? Yeah, the whole reason we had to log was because we could use that great rule that allows us to bring our log downstairs. And as soon as it's downstairs, we can deal with it. Okay, so we end up with log 18 over 10 equals x log 1.05, and we finish off by doing what, peeps? Yep, get rid of the times, divide. Some of you are still guessing. Is it going to be log 18 over 10 divided by log 1.05, or is it going to be log 1.05 divided by log 18 over 10? Grace? What's my next line? Well done. And now, to the Batcave, Batman. To the calculator. What'd you get? Yeah, and that is exactly what we got, and you would say years. That's what we got from technology. So, I'm talking test, I'm talking common test. If we were to squeeze in, which thank God we called that we weren't having a test for this unit, because that was crazy. No lesson tomorrow. This is a typical exponential question. Instead of having money in the bank, it could be, as we said, number of bacteria. It could be number of rabbits, mice, kangaroos, etc. All I can do is change the theme and the numbers. Correct? Okay, we're going to menu. We're going down into finance. Yep. Grace, are you with us? Okay, so we're going into finance. And as you can see exactly, we've got compound interest, so we go F2. And we can just enter. And this is how maths has changed. So we used to do a lot of calculation, whatever, year 9 still have to play with the FV, PV sort of thing. But hopefully now year 10, they might be asked, you might ask to be doing it using logarithms. You can check on your calculator. So here we go. What do we think n is? No, n isn't 10,000. N is 15. Interest, please notice, we don't have to put 0.05. The calculator automatically, it's got percent here, so we just say 5%. I know, it's so good. Here's the thing you got to watch for. When we're doing the PV, you have to go negative 10,000. And before you say why, it's just how it works in the formula, okay? So 10,000. We're going to look at this in a moment. PMT, we're going to use that in about 5 minutes because that's what most of us do when we save. I don't know about you, but I don't have the spare $10,000 that I can just go, ooh, bang, let's put this away. It's, I get paid every fortnight, and then you make regular repayments, right, into a savings account. At the moment, we're not doing that, 0. We don't know our future value. Payment, regular payment. And we're talking about this once per year. Okay? Ready? We can just, are we all good? You change PY to 1, everything changed to 1. Well, CY changed to 1 as well, not everything. Oh, you want to find out what your future value was? Isn't that what we got from the calculator at the beginning? Yep.
So you could do this instead of this graph.
What about this? We wanted to know how long did it take for the future value to get to 18,000. So I can make my future value 18,000. And what did we want? How long? I can press N. What if, what if we had, it was for 15 years, but I now wanted, I needed $30,000 after 15 years. What interest rate would I need for that to occur? Tell them you're dreaming. You're not going to find 7.6% interest rate. Adjust your expectations, right? This is amazing, this section of the calculator. And I apologise probably to Grace. No, you might be here. But Rosie, maybe the volleyballers, because we will actually have a look at this in more detail and superannuation before we leave, because you've got to know it.
Wait, when we do that? Wait, before the commentary?
No, after.
No, the commentary.
Superannuation is, it comes out of your pay packet. If you are employed by somebody, they are under a legal obligation that they have to do that, and it goes into a fund. For me, mine goes into a government fund. I've got no say in it. For other private industries, you could choose the fund that you want to put it into. One might be better than the other. That's the dodgy bit. The idea is that when you retire at 65 or 70, whatever, whenever the age is, you can then live off that money rather than have the pension, because the pension's not enough. They can't afford to do that for everybody. So you have to become, or what they're wanting, a self-funded retiree. So your employer's going to put in, at the moment, I think it's 10.5%. Like, I don't even look. It just goes in. It should be by next year or the year after, I think it's going up to 12.5%. Anyone know why?
It's the inflation.
Bit of inflation, bit of they're adjusting to that, you know, they've looked at now the average retirement fund isn't big enough. So what you need to do also is you want to add in addition to your employer. Okay? So we're going to take the situation where we've got an employer. This is just a rough idea because we're going to assume it's the same amount right from when you start working. But what normally happens when you start working to maybe 10 or 20 years later? What happens to your salary? It goes up. So we're just going to assume a bit of consistency at the moment and just want to show you the difference between contributing early and not contributing. Do you know this, or am I boring you? Sorry, bit of both. So we're watching. All right, we are going to, when are we going to start working? Let's have two. We'll have Rosie and we'll have JPB. So they both start working at full time. Right? They both are from their employers. Their employers are both popping in, let's say, 450 a fortnight. Doesn't matter. It's going to change. And Mr. Twister here decides he's also going to contribute an extra $50. So he's putting away just an extra $50 a fortnight. That's $25 a week. Not much, right? Let's have a look at the difference. So we go out here. We doing? Okay, so we are retiring at 65. I'm hoping to retire a bit earlier, but anyway. Anyone? That's when we started. Did I say 21? I said 22. 65 minus 22. Now, we are making payments. We are making payments every fortnight. So we have to times by 26. So you missed that because you're talking. So 65 take 22. We're doing it every fortnight. So we times by 26. Got? Okay, interest rates. In super funds, 1 year my super fund was 20%. The other year it was negative. Like last year, negative 20-something%. Goes up, goes down. But we'll take an average of, let's say, 6%. That's pretty low. You have nothing to start with. How sad. So this is Rosie. We ready? Rosie is going to contribute $4.50 a fortnight. So we're going to go, because there's no PV, our PMT is minus. So minus $4.50. No future value. How many payments per year is she making? Fortnight.
26.
Shh. Okay. How much is Rosie going to end up with? I think I got that wrong.
That's what I got. Let's go on range.
Rosie.
Give me one.
Shh.
I think she's letting tax problems.
Maybe.
Where's the 26 from again?
Shh. 118. Yeah. Anyway. Bit over the top. I think I'll be lucky if I get 1 million. And I'm contributing $700 a fortnight. But I haven't been doing that forever. I'm doing it late. Anyway, look, keep that. Shh. Keep that. Ready? $450 more. $50 more. So, we're doing JPB. So can someone write that down? I better. 2365128. 2365128. All right, ready? Minus 500. And before you press your future value, can I ask you to think about this? So how much extra is JP putting in? He's putting an extra $50 every fortnight for 65 take 22 years. So he's putting in an extra 55,900. Hey, let's round that up to 56,000, yeah? So he's making an extra 56,000. What is 128 plus 56,123. So 2.4, yeah? Let's go back to our finance. How much more than 2.4 do you think JPB is going to get? So future value. You probably missed one thing there.
Yeah, Jack. No, but when you think about it, that money has to last until like for 25 years.
It is, yeah.
Think about how much money you're already not.
Shh. The point is, peeps, is as soon as you get a full-time job, you contribute, and I would say contribute 5% right from the get-go. What will end up happening, see, constantly, they talk. What will end up happening is you will end up with a lot more in your super account when you retire than if someone who says, oh, I'll do it next year, I'll start next year, I'll start a little bit later. So that was me. I started when I was 35. I will have contributed a hell of a lot more and have less in my bank account than someone who started at 21, 22. They would have contributed less of their money, but they would end up with much, much more. It's the compounding effect, right? The fact that we do this. So if I started late, right, I've got like this. You start early, you're going for longer, you get this much bigger increase. So for superannuation, soon as you get your full-time job, hello, can I please make a 5% salary sacrifice contribution? Make sure you do it.